Hello, boys and girls. Today we will see the next topic of the oscillations. Last time we have seen the differential equation of simple harmonic motion, and differential equation was d2x by dt square plus omega square x is equal to 0. So this is the differential equation for the simple harmonic motion, and this differential equation is very useful to describe or derive the equations for acceleration in the simple harmonic motion and velocity of the particle in the simple harmonic motion, or the displacement of the particle in the simple harmonic motion. So these equations, means equation for acceleration, equation for velocity and equation for displacement, we can derive these equations starting from differential equation of the simple harmonic motion. So let us derive the equations. Let us derive the equations for acceleration, velocity and displacement of the particle in the simple harmonic motion. So let's see the expression, how we will express or how we will derive the expressions for acceleration, velocity and displacement. Let's see acceleration A, velocity V and displacement x of the particle in the simple harmonic motion. So this is the simple harmonic motion of a particle in which position O is the mean position, and these 2 points are called as the extreme position. So at the extreme position, we know displacement is always maximum. Displacement is always maximum at the extreme position. So this is the extreme position. From this mean position, the displacement is maximum. The value of displacement is the maximum, beyond which means beyond extreme position the particle cannot move. So displacement will be maximum at the extreme position, and that displacement at the extreme position is called as the maximum displacement, and maximum displacement is called as the amplitude of the simple harmonic motion. So let's see the expressions starting from the differential equation of the simple harmonic motion. So this is the differential equation. This is the differential equation, d2x by dt square plus omega square x is equal to 0. So arrange this equation. We know this is the first term, this is the second term. What is the first term? d2x by dt square. So what do you mean by d2x by dt square? It is the acceleration. It is the acceleration. As we know, this is the first term which is acceleration. Second term will be also a acceleration. So rearrange this equation, d2x by dt square then is equal to, shift this at the right hand side, we get minus omega square x. Minus omega square x. At the left hand side, d2x by dt square, this is the term, only single term. This term has meaning as a acceleration of a particle in simple harmonic motion. So d2x by dt square, it is nothing but the acceleration of the particle in the simple harmonic motion, and a d2x by dt square means acceleration, and it is always equal to minus omega square x. So this is the first equation. First equation which gives the acceleration of the particle in this simple harmonic motion. So this is the equation 1, and equation 1 gives the expression or equation for the acceleration of the particle. So acceleration of the particle depends on the displacement only. Depends on the displacement only. As we know, omega, that means the angular velocity, it is always constant for the given simple harmonic motion. So acceleration only depends on the displacement. As the displacement is more, acceleration will be more. As the displacement is minimum is 0, means acceleration will be 0. So acceleration will be 0 at mean position because of the displacement is 0 at mean position. Let's see the next expression. Next expression is for velocity. So now we will derive a relation or expression for velocity of the particle in the simple harmonic motion. Now see, velocity is indicated by v, and we know the equation, last time equation, d2x by dt square is equal to minus omega square x, right here d2x by dt square is equal to minus omega square x. So left hand side is the acceleration and right hand side is also acceleration. Now we know d2x by dt square can be expressed in this way. We know this is the acceleration, and acceleration means it is the rate of change of velocity with respect to the time. So acceleration is the rate of change of velocity with respect to time. That means d in the bracket dx by dt. What is meant by dx by dt? Dx by dt means velocity. Dx by dt means velocity. Means derivative of velocity. Derivative of velocity with respect to time. Derivative of velocity with respect to time means nothing but the acceleration. So acceleration can be written in this way. In this way, that means the derivative of velocity. Velocity means dx by dt with respect to time. That is the acceleration. And right hand side will be same. Right hand side will be same. So change this equation, convert this equation in this form. Now we know dx by dt means velocity. Dx by dt means velocity. So this equation will get reduced. Will get reduced in dv by dt. In dv by dt. So this equation becomes dv by dt at the left hand side. Right hand side will be same, minus omega square x. So this is the velocity. V means dx by dt. So dx by dt means v. Okay. So right in the next line, adjust this ratio dv by dt. dv by dt can be written in this way: dv by dx multiplied by dx by dt. dx by dt. This dx and dx will get cancelled, so we get the previous term. Previous term is dv by dt. So we can write this dv by dt in this way for the simplification. For the simplification, so dv by dt means dv by dx multiplied by dx by dt. So this dx and dx we can cancel it, so that we get the previous step. So dv by dx, dx by dt. Then next line, dx by dt means dx by dt. dx by dt means it is v. So right here dx by dt means v. And then remaining dv by dx. dv by dx. Right hand side will be same. Then at the left hand side, this is the left hand side, this is the right hand side. See, at the left hand side we are getting two variables. First variable is the velocity and second variable is the displacement. So first of all we have to separate the variables. Take first variable at the left hand side and another variable at the right hand side. So rearrange this equation. Take this dx term at the right hand side, so that v dv, v multiplied by dv. dx is taken at the right hand side, so right hand side becomes minus omega square x multiplied by dx. So this arrangement is very important while determining the relation for the velocity. Now after this step, now we have to integrate this relation. We have to integrate this relation. So integrating both sides we get. First side, right hand side, we have to integrate the relation. So integrating both sides we get. So v dv integration. v dv is equal to minus sign. Now at the right hand side, x is variable, dx is also a variable, similar variable, but omega square is a constant. Omega square is a constant. So while solving the integration part, the constant terms always we have to take outside. So negative sign outside omega square, as it is constant, so take it outside. So remaining things will be x dx. Write these remaining things, these variables inside the integration sign. So minus omega square x dx, on integrating we get minus omega square integration of x dx. Integration of x dx. So solve this equation by using this hint. Okay? That means integration of v dv is equal to, what is the power of integration, what is the power of v1? So means we can write here integration of v dv means v to the power plus 1 divided by power plus 1. As we know power is 1, so v to the power 1 plus 1 divided by 1 plus 1. So we get v 1 plus 1 means 2, means v square, and divided by 1 plus 1 means 2. So integration of v dv means v square by 2. So v is the one of the variable. By considering one of the variable, we can write a formula, basic formula for the integration, and the formula is integration of v dv. It is always v square by 2. Instead of v, we can consider x, means integration of x dx. Integration of x dx, it will be x square by 2. So using this hint, we can simplify the relation. Integration v dv means v square by 2 equal to minus omega square. Integration of x dx means x square by 2. So left hand side and right hand side integrations we have solved. But after simplifying the integration, we have to add some constant. Always we have to add some constant to the solved integrations. Left hand side answer is v square by 2. At the right hand side answer is minus omega square x square by 2 plus c means constant of integration. We have to always consider a constant of integration after completing the integrations, after solving the integrations. So plus c we have to add where c is constant of integration. So let us decide the value for constant of integration. While deciding the value of constant of integration, we have to consider a single situation, that means the extreme position. So while performing simple harmonic motion, when particle reaches to extreme position, so what happens? When the particle reaches to the extreme position or the another extreme position, the particle will momentarily get stopped. So particle gets stopped or acquires velocity 0 or minimum velocity at any extreme position. Means at extreme position, the particle has a minimum velocity, means 0 velocity. And at extreme position, we know this is the mean position, and at extreme position, displacement will be maximum. Displacement will be maximum on either sides. So displacement means x. Displacement means x. We get positive displacement this side, means plus a. Maximum displacement indicated by a certain symbol, that is the capital A. So at the positive side, the maximum displacement will be plus a. At the negative side, this side, the maximum displacement will be minus a. So displacement at extreme position, displacement x will be maximum, and it may be positive maximum or negative maximum. It means plus minus a. So at extreme position, this is the maximum displacement, that is indicated by a, and this is x is equal to plus minus a, maximum displacement at extreme position, and velocity will be minimum. Velocity will be minimum means v is equal to 0. So these two values we have to place in the previous equation number 2. So equation number 2 becomes now. We get equation 2. This is the equation 2. V is 0. V is 0. So 0 by 2 means 0. Equal to minus omega square x displacement. X displacement is this positive negative, that means the maximum. So instead of x we have to capital A. We have to write the capital A. So a square by 2. So minus omega square a square by 2 plus c. Now rearrange this equation. Equate c. C is equal to omega square a square divided by 2. It becomes the positive. So value for constant of integration c will be omega square a square by 2. So place this value of constant of integration in the equation number 2. So equation number 2 becomes v square by 2 equality sign negative minus sign omega square x square by 2 minus omega square x square by 2 plus c means omega square x square by 2. So right here the value for c omega square a square by 2. Then 1 by 2 are common, so we can cancel it. So remaining things will be v square. 1 by 2 will get cancelled. Remaining things will be v square is equal to, at the right hand side there are two terms, first term and the second term. So first term is negative, second term is the positive. So write positive term always initially. Initially we have to consider always a positive sign. In both the terms omega square are common factor. So omega square will be common. So in the bracket positive term is a square. We have to write first a square minus x square, negative x square minus x square. So this will be the equation. V square is equal to omega square in the bracket a square minus x square. Now take the root. Find the square root. We know v square root is v is equal to, this is the complete single term. We cannot get a standard square root answer for the right hand side. So only we have to write omega square root is omega square root is omega, but this is the bracket term. This bracket term we have to write in the square root form. So in the root a square minus x square. So we have to write here plus minus sign, means the root may be positive or negative. So both values are possible while finding the root. So velocity square root is v. At the right hand side the root will be positive or negative omega under root of a square minus x square. This is the next equation number 3. So this equation is the required expression for the velocity of the particle performing simple harmonic motion. Now the remaining equation for the displacement. So this is the now remaining expression that we have to derive. So for displacement, we know in the previous equation this is the velocity. But velocity means dx by dt, rate of change of displacement with respect to the time. So v means dx by dt is equal to at the right hand side positive negative. Leave these values or signs positive or negative. Consider only magnitude of velocity. So velocity, right in the next step only magnitude form. So left hand side v means dx by dt. At the right hand side omega under root a square minus x square. Here also at the left hand side x is the first variable and time is the second variable. We know the displacement means x always changes with the time. Means displacement is changing with the time as time is naturally changing. So these two are variables are present at the left hand side, we have to separate them. We have to separate them means one variable at the left hand side and another variable at the right hand side. So keep this dx as it is at the left hand side, but at the right hand side this is under root of a square minus x square. This under root term has the same variable x. So in under root sign there is same variable x present. So take this at the left hand side. So we get dx. Take this left hand side at the denominator under root a square minus x square is equal to omega. Keep at the right hand side omega, but dt another variable, shift this at the right hand side. So we get omega dt. So this is the variable separation. This is the variable separation step. After completing the variable separation step, then we can find the integration. So taking integration on both sides. So integration for the left hand side, integration dx divided by under root of a square minus x square. Now at the right hand side is equal to at the right hand side. As we know, omega is constant. So omega is constant. Omega is constant. Take it outside of the integration sign. dt, that means the variable, keep it inside the integration sign. So integration of dt. So integration of left hand side is equal to integration of omega at the right hand side, integration of omega dt. So now we have to integrate. At the left hand side. So this is the standard formula for the integration. One of the standard formula. And that standard formula is given here as a hint. When integration of 1 upon some constant square minus variable square. So constant is a, variable is x. So 1 upon a square minus x square with respect to the dx. It is always as sine inverse of variable upon constant. As we know, variable is x, so x divided by constant is a, so divided by a. So integration of 1 upon a square minus x square with respect to the dx, it is always sine inverse of x upon a. So at the left hand side, the answer will be integration of dx divided by a square minus x square. It is nothing but the sine inverse of x upon a. So sine inverse of x upon a is equal to omega is integration of dt always the t. This is again a simple basic formula for the integration. It is integration of 1 with respect to the time. Integration of 1 with respect to the time, it is always the time. Or integration of dt means it is always t. So omega is a constant. If we keep the constant as it is, then integration of dt means t. So integration of this combination will be omega t. So after completing or after solving the integration of all the terms, lastly we have to add a single constant, and that single constant we have to always add after simplification, and that constant is called as the constant of integration. In this case, the constant of integration will be different. So plus 5 means constant of integration. Here 5, it is the constant of integration. So last time we have solved sine inverse x upon a is equal to omega t plus 5. Take this sine function at the right hand side. So we get remaining will be x upon a left hand side, remaining will be x upon a. Now shift the sign inverse at the sign, we get a sign plus 1. Here is sign minus 1. When it shifted to the right hand side, it becomes sign to the plus 1. So sign to the plus 1 means only sign, and this sine function or harmonic function will operate on the right hand side. So sine and right hand side is omega t plus phi. So sine will get operated, sine will operate on the right hand side is omega t plus phi. So x upon a is equal to sine omega t plus phi. We have to derive a relation for the displacement. So equate the displacement. So x is equal to, shift the a at the right hand side. So x is equal to a sine omega t plus phi. So this is the required expression for the displacement of the particle in the simple harmonic motion. Means in the simple harmonic motion we can decide or we can find the displacement of the particle at any instant t. As time changes, displacement also changes. And phi is the constant of integration. It is always a constant. Phi is always constant, and its value depends on the starting of the simple harmonic motion. Means initial position at the start of the simple harmonic motion. So this is the required expression for the displacement. So these are all process. This is the process to derive the different relations, like acceleration A given by equation number 1, velocity V given by equation 3, and last displacement given by equation number 4. Okay, thank you.